Hello again. Here is question 18. The graph of the function f of x is there, so we don't know what that equation actually is. We just call it f of x, kind of curvy and wiggly. And we've got to estimate the integral between 12 and minus 3. Okay. Well, we'll use the areas to help us do that. So there'll only be approximate areas because we don't have the exact function going on. But down here, we can definitely approximate that with a triangle. Now, the area of any triangle is equal to a half the base times the height. The base of this one goes 3 across and the height 2, 3, that's 3. So 3 3s are 9 and a half of that is 4.5. Over here we can do some more approximating. Let's draw that triangle. The base of that will be 6 and the height, again halfway between the 2 and the 4 is 3. 6 3s are 18, but a half of that gives you 9. Let's put a bit of a rectangle in here. And where the base is 3 and the height is 3, 3 3s are 9 for that rectangle, square. And on the right hand side, very bad looking triangle, but we'll just estimate it's 3 there and 3 there. 3 3s are 9 and a half of that is 4.5. So we're now going to use those areas to estimate that integral. Here we go. The integral between 12 and minus 3 of f of x. Now, we are not asked to find the area between f of x and the x-axis. We are only asked to evaluate the integral, and that's a very, very different thing, because when you're evaluating the integral, those parts of the curve that are above the x-axis, when you integrate them, you will get a positive value. Those parts, like on the left-hand side, that are below the x-axis, that will give you a negative value when you just do the integral. So in this case, what our integral will be is 9 plus 9 plus 4.5, because those values are above the x-axis, they are positive, but on the left-hand side, the 4.5 on the left, that'll be a minus 4.5. And I should say this is approximate only, so I'll just put a wiggly line here. That's approximately equal to that. The 4.5 above the line, the 4.5 below the line, approximately cancel each other out. And we are just left with an approximate value of 18 for the value of that integral. So the trick here, if you like, was that you had to be very clear in your head that the integral between an upper and a lower bound, or between two bounds, is not the same as the area between that curve and the x-axis. Okay, that's that for that one.